Understanding the distinction between balance, ununs, and common mode chokes is a rite of passage in RF engineering and homebrewing. These devices all manipulate RF currents and impedance, but they solve very different problems in your feedline and antenna systems. Here is a breakdown of how each works, why they are used, and when you actually need them. Balance to unbalanced. A balun connects a balanced system to an unbalanced system. The unbalanced side, coaxial cable. The center conductor is shielded and referenced to ground, the outer shield. There are two currents on the shield, on inner aspect and outer aspect. The last one is an unbalanced common mode current. The balanced side, a symmetrical antenna such as a center-fed dipole or a moxon. Both sides of the driven element are electrically equal and neither is tied to the ground. Why you need the balun? If you connect a piece of coax directly to a resonant dipole, the system is mismatched. The RF current traveling up the center conductor goes into one leg of the dipole, but the current returning on the inside of the shield splits. Some of it goes to the other leg of the dipole and the rest travels back down the outside of the coax shield. Your feedline has just become part of your antenna, which distorts your radiation pattern and changes your resonant frequency. A balun forces equal currents into both halves of the balanced antenna, preventing this issue. Common types: 1:1 balun, used when the impedance of the coax matches the antenna. Example, 50 ohm coax to a 73 ohm dipole. 4:1 balun, used for impedance transformation alongside the balancing act. Example, 50 ohm coax to a 200 ohm folded dipole or off-center fed dipole. Unun, unbalanced to unbalanced. An unun connects an unbalanced feed line to an unbalanced antenna. Its sole purpose is impedance transformation. The scenario: you are feeding an unbalanced antenna like a quarter wave vertical or an end-fed half-wave wire. Why you need the unun? An end-fed half-wave antenna has an extremely high feed point impedance, often between 2000 and 3000